Welcome. In A part of lecture first, here we will cover the topic classification of linear partial differential equation of order 2. We will practice various important questions asked in various competitive exams, IIT JAM, CSIR NET, MSc entrance exam, and in your GATE examination also. And this lecture is base lecture for your practical first problem solving part A. So let us take what is the first practical first and then solve these questions. Your first practical is to practical problems to reduce partial differential equation into canonical form and then solving those. So for doing this practical, we first know what is second order linear partial differential equations and its classifications. I am writing here just the standard form, general form of linear partial differential equation of second order, and its general form is capital R small r plus capital S small s plus capital T small t plus this is a function of x, y, z small p and small q equal to 0. And in your last semester you studied that z is function of two independent variable that are x and y. This p, this small q, small t, s and r, these are the first order and second order partial derivative of this dependent variable with respect to these two independent variables respectively. And also this r, capital R, s and t, this may be the function of x and y, and in some portion these are constant. And one important thing is here, this dependent variable, that is your z, and these coefficients, that is capital R, S and T. These are twice continuous differentiable in the given domain omega. And first of all, what is this P, Q, small r, S and T? In previous class you studied that this P is nothing but partial derivative of z with respect to x, and this Q is equal to partial derivative of z with respect to y, and small r, that is 2 times partial derivative of z with respect to x. You can write this as like this also, curly by curly of x and curly z by curly of x. Sometimes this notation is zxx. So it's your small r. Then this small s is partial derivative of z with respect to y, and then x. You can write this is also equal to curly square z, curly y, curly of x. Now the classifications. To do this practical, we first need know that the given equation is elliptic, hyperbolic or parabolic. For this we write the principal part of equation first, and the principal part is given by this expression capital RR plus SS plus TT. In equation here, this equation is curly r by curly x of this. I can write this is equation number 1, and this principal part divide the classification of this linear partial differential equation of second order. Here I identify the value of r, capital S and capital of T, and this partial differential equation is elliptic if the value of s square minus 4rt is negative, and if this is equal to 0, then this differential equation is known as parabolic in nature, and if this value is greater than 0, it is called hyperbolic. So we will first solve this list of 12 questions where we have to classify the given partial differential equation as elliptic, parabolic or hyperbolic, and then we will find the canonical form. I will tell you what is the canonical form and how to find the canonical form of the given differential equation first. Here is the list of questions. You have to classify the following partial differential equations, and the list is: question 1 is curly square z curly x square equal to curly square z curly y square, and second question is one dimension heat equation. In this way, these are the list of important 13 questions. In today's lecture, I will solve the first 3 questions and remaining 3 in the second part, and so on. In first part, I will solve all these 12 questions. These are the list of 12 questions, and in the second lecture, where I will solve the problem practical first, there we will find the canonical form of all these equations. So let us solve first questions. I can write the equation 1 in this way. I am taking this on the left hand side, so it becomes this one. Now partial derivative of z with respect to x2 time, it is your r. I told here curly square z curly x square, curly square z curly x square, this value is r, and curly square z curly y square, this is curly square z curly y square. So this value is capital T and small t. So I can write this is in the standard form: 1 into small r plus minus 1 into small t is equal to 0. Now comparing it with r, s plus tt plus the function of x, y, z, p, q is equal to 0. It's my first equation. If you make the comparison, r is here, this capital R is equal to 1. Here no value of s, so capital S value is equal to 0, and capital T is equal to minus 1. Now calculate the value of s square minus 4rt. I told you these r, s, t may be function of x and y or constant. Here is the case of constant coefficients. So calculate the value of s square minus 4rt. This is 0 minus 4 into r into t. Its value is equal to positive 4. So it is greater than 0. So nature of my partial differential equation, this is the case. Now you have to identify, I think this is greater than 0. So my partial differential equation is hyperbolic here. So I can write that equation number, suppose I am writing equation number 2. Suppose this is 2. So I can say here equation 2 is a hyperbolic partial differential equation. Okay, now read the second question. The second question is curly square z. This is my second equation. Curly square z curly x square minus curly z by curly y equal to 0. Now again it can be written as curly square z curly x square. This is small r. There is no terms of small s, t and this is q here, that is equal to 0. Now again comparing it with the standard form general equations. So capital R value is here 1, the value of S is 0, and value of T is again 0. Now calculate the value of S square minus 4RT, and it is 0 minus 4, R is 1 and T is 0, this is 0. So according to rule, this equation can be classified at the case number 2nd, that is it is a parabolic partial differential equations. So write down, this is equation number suppose 3. So you can see here 3 is parabolic partial differential equation. Okay, this is parabolic partial differential equation. Now take the question number 3rd, and the question 3rd is curly square z curly x square plus curly square z curly y square equal to 0. Its name is two-dimensional Laplace equation. In future you will study the three-dimensional Laplace equation also. So there are 3 type of equation in your syllabus in unit 3rd also: wave equations, heat equations, and Laplace equations. Here the question first is example of one-dimensional wave equations. This is one-dimensional heat equation example, and this is two-dimensional Laplace equations. So now to find the nature of these classifications, again compare this with RR, SS plus TT plus function of x, y, z, p and q equal to 0. Here 2 time partial derivative with respect to x, so it is small r. So my equation is this one. In examination, the question can be written in the form of r plus t equal to 0, where r and t have the usual meaning. So you should know what is the r and what is t here. Now comparing the coefficient here, here is 1, here is also 1. So capital R value is here 1, and capital T is again 1, and the value of S is equal to 0 here. Now calculate the value of S square minus 4RT. So S square minus 4RT value is equal to 4RT. S is 0 minus 4, 1 into 1, it's minus 4, and this is negative. So write this equation number 4. So equation 4 is here. You can write equation 4, and partial differential, linear partial differential equation second order, that is r plus t is equal to 0, is an elliptic partial differential equation. Okay, in this way you can calculate the remaining 10 question also. In the next lecture I will solve the next 4 questions, and the third lecture I will solve the next 5 questions, and in second lecture we will calculate the canonical form. Okay.